Okay, so I have another video of an introduction to MRAM, RRAM, and LRAM, which is a little longer. So if you want more detail, definitely go to that. But quick introduction: MRAM stands for Middle Rectangular Approximation Method. RRAM stands for Right Rectangular Approximation Method. And then you probably can guess what LRAM is. So what those are doing is those methods are helping us approximate the area under a curve. So if you've got a function like this, maybe this is miles per hour of some sort of vehicle, like a drone or a car or something like that. If you found the area under the curve, you'd be finding the total distance it traveled, right? Because if this is your speed, then this area under here tells you how far that vehicle has traveled. So we want to know the area under the curve, and so to find that, it's not like a regular shape where we could use area of a circle or area of a rectangle or anything like that, but we can approximate it with a bunch of rectangles. So what we do is we cut up this area into subintervals, and they all have to be the same length. I guess they don't have to be, but it helps probably to make it more consistent, maybe avoid problems. I got to think about why we would want to make sure they're the same subinterval. So I've got subintervals of length 1. And then what we do is we draw a rectangle to approximate that area. And what type of rectangle just depends on which method you're using. So if you use MRAM, then look at your subinterval. The middle value dictates how high that rectangle is. So I'm trying here, this is like a dot right in the middle between 0 and 1. That is the height of my rectangle. Okay. Then between 1 and 2, 1.5 looks to be the middle value. So if I follow that straight up, that looks to be about where 1.5 is. Between 2 and 3, so 2.5 is my middle x value. If I follow that straight up to my function, this looks to be an approximation of where that middle y value is. So that's our rectangle. And you can keep going in this fashion. You can see how it's overestimating but underestimating a little bit, underestimating but overestimating the area of the curve. So it gets us a rough idea of what that actual area under the curve is. Computers do this, and when computers do it, they just take really small subintervals because it doesn't take a computer any time to make a calculation, right? It does, but it's so small that it doesn't really matter. So a computer will take a ton of subintervals, just really, really small. Okay, so that's the basic idea. This time in my other video, we did a discrete function. We're going to do a continuous function for this one. And so we're asked to make an MRAM, RRAM, and LRAM approximation on this interval where A equals 0 and B equals 3. So this is just what our textbook was saying so that they could easily define this problem from multiple questions. In other words, between 0 and 3. And so I've said let's just do subintervals of length 1. And this is in our graph. That's one I made. So this function, you could graph it to help you if you want. It should be a parabola. I think I made it so it's factorable too. Yeah, two numbers that multiply be -2, so x plus 2 and x minus 1. So what that tells us is that it should cross at -2. This isn't required, okay, but it will help if you have a sketch. If this is your first time doing it. And x equals 1 is right here, and it's an upward facing parabola, so we know it should look something like this. Because a is positive, that's why I know it's going this way and not this way. Okay, there is our parabola. You could get that from desmos.com real quick if you wanted. We just need a rough sketch. And so what we're going to do is we're only considering from x equals 0 to x equals 3. So we're only considering this part of the graph, and we're trying to approximate the area under the curve. So we're going to get a little bit of negative area to start because this is below the y-axis, the x-axis, right? Because it's negative. But subintervals of length 1 means that from 0 to 1 is a subinterval, from 1 to 2 is a subinterval, and from 2 to 3 is a subinterval. So I'll do MRAM first. MRAM means I look at the middle part of these intervals and I find the y value that corresponds to those middle parts. So this looks to be about where the graph is halfway between 1 and 2. I'm going to calculate the area of that rectangle, and then once I calculate the area of all the rectangles, then I've got my approximation for the area under the curve. Between 2 and 3, 2.5 is the middle point. If I follow that straight up, this is a rough sketch of where it is on our graph. And then between 0 and 1, This one's going to have to go below the x-axis. We should have negative area here. We'll want to keep that in mind. We got to make sure we use a negative sign. Okay, and that one's going to be pretty small. And so what are these y values, you might be thinking? Well, all you have to do is plug in 0.5 into our function to find out the corresponding y value. Okay, so I'll make a quick data table for MRAM. I'm plugging in 0.5 because that's my first middle point between for my first interval. So 0.5, if I plug that in, 0.5 squared plus 0.5 minus 2, that's negative 1.25. And so the area of this rectangle is 1 across and negative 1.25 down. We just found out the y coordinate is negative 1.25, so it goes down negative 1.25. So 1 times negative 1.25 is negative 1.25. Okay, but we'll want to add them all up. So the next one, the middle point between 1 and 2 is x equals 1.5. And if we plug that into our function, 1.5 squared plus 1.5 minus 2, that's 1.75. So the area of this rectangle is 1 to the right and 1.75 up. So length times width, 1 times 1.75 is 1.75. So this subinterval is real nice because it makes the calculation real quick. It's going to be whatever the y value is, right? And between 2 and 3, 2.5 is our x value. And so if we plug in 2.5 into this function up here, we got to do 2.5 squared plus 2.5 and minus that 2. So the y value is 6.75. So the area of this rectangle is 1 across, 6.75 up. So 6.75 is the area. 1 times 6.75 is 6.75. And then if you add those up, you've got your approximation. So 7.25 is our approximation for the area under the curve with MRAM. Okay, this video is getting long. I'll do RRAM, and then hopefully that'll illuminate what we have to do for LRAM. But okay, so let me re-sketch the graph because I can't go back. So this is roughly our curve. And then we had 0 to 1. Oh wait, it crosses at 1, right? Yeah. So 0 to 1, 1 to 2, and 2 to 3. There's our 3 subintervals because we're supposed to be estimating the area under the curve just between these x values and the subintervals of length 1. If that said length 0.5, then I'd be making subintervals like this. 1 to 1.5, 1.5 to 2. Okay, so I'll do RRAM next, and hopefully that maybe I can get you started on LRAM. But RRAM says look between 0 and 1 and use the right side of your interval to find out the height. So we could do a table again if we want. If I plug in 1 into my function, I can already tell it's going to be 0, right? Because if you plug in 1 into this function, 1 squared is 1, 1 plus 1 is 2, 2 minus 2 makes 0. So this first rectangle has actually got no height. It's got an area of 0. Okay. So we'll move on to the next subinterval from 1 to 2. The right side of that interval is at x equals 2. And we need to know what the y value is if we plug in 2 up here. 2 squared is 4. 4 plus 2 is 6. 6 minus 2 is 4. So that's our y value. Okay, so the height of this rectangle, we draw the height based on the right side of the interval. So this is over approximating the area under the curve, right? This is the actual area under the curve, but to follow RRAM, we calculate the area of this entire rectangle. So the RRAM area is 0 for the first one, and then it's 1 across, 4 up, so 1 times 4 makes 4 for the second rectangle. And the third rectangle, we use the right side of the interval to dictate the height of our rectangle. If you kept the curve going, that's roughly where it would cross. So if I plug in 3 up here to find out what that y value is, 3 squared is 9. 9 plus 2 is 11. 11 minus, I'm plugging in 3, not 2. Sorry. 3 squared is 9. 9 plus 3 is 12. 12 minus 2 makes 11. So this is 3 in x and 11 in for y. So this has a height of 11, right? And then the length of this rectangle is still 1. So 1 times 11 makes 11. So that makes 15. That's our RRAM approximation, okay? So if you're going to do LRAM, here's our curve again real quick. LRAM, you'd use the left side of those intervals. Oh boy. Kind of zoomed in my graph here. But I'd use the left side of the graph to dictate the height. So this is what your rectangle should look like for LRAM, because at x equals 0, the y value is down here. At x equals 1, the y value is right here. So that has no height. We've got this rectangle plus a rectangle of 0 for area. And then for this interval, 2 to 3, I use the left side of my interval to dictate the height. So that would be the third rectangle you got to find.